All right, today's lesson is 8.2 and it's estimating a population proportion. So 8.1 dealt with understanding and learning what confidence intervals are and how to interpret them. And today we're going to focus on how to construct a confidence interval both by hand and on the calculator. And then take a look at a sample size for margin of error and just get into margin of error a little bit. So let's go ahead and get started. So some of the examples we have that we're interested in estimating what that population proportion is or what that p-value is. So some examples of that is like what proportion of U.S. adults are unemployed right now, or what proportion of pine trees in a national park are infested with beetles. Or the last one, which none of you would ever do, is what proportion of high school students have cheated on a test. So we want to look at those proportions and try to figure those proportions out. So when we do that, we're going to use a one sample z interval for a population proportion. Even though that sounds like a whole lot, it's really not too bad. So it says, when we do that, it says when the conditions are met, there are three conditions we're going to look at in a moment, a C% confidence interval for the unknown proportion can be found by the following. So we have our p hat, which is our sample proportion, plus or minus our z star, which we're going to look at what that is in a second, multiplied by the square root of p hat times 1 minus p hat divided by n. So that little part right there should look a bit familiar to you. So it says right down here, I told you we were going to come back to what that z star is. Z star is the critical value for the standard normal curve. So z star is primarily just our critical value. Okay, and we're going to find how to find that value in a little bit. All right, so it says with C% of its area between negative z star and positive z star. This is called the one sample z interval for our population proportion. So as I said earlier, there had to be conditions that needed to be met, and there are three conditions, and they're all found in this formula. So I have them numbered, and then I have the formula little parts of it numbered so you can see where they all come into play. The first one is that it needs to be a random condition. All right, so to be sure that p hat is a valid point estimate, we looked at point estimate the first day in 8.1, we need to check that it's a random condition. We need to make sure that the data comes from a random sample of the population of interest. To me, that only makes sense for it to be the population of interest. We don't need it to be of some other population that has nothing to do with what we're talking about. So for that, mostly you want to just look in the problem, does it say it's a random sample? The second condition we need to make sure that is met is the large counts condition. We've gone over this before. It says when the large count condition is met, we use a normal distribution to calculate the critical value z star for any confidence level. It says if we don't know the p-value, we replace p with our p hat value, which is our sample proportion. And then we can check it by using our large counts condition. So that means we need our n times our p hat. Remember, usually it's n times p greater than or equal to 10, or n times 1 minus p greater than or equal to 10. But a lot of these times we're not going to know the actual population proportion. That's what we're trying to figure out. So we need to use our sample proportion in place of that to make sure both of these conditions are met. So that's why it looks very familiar, but it's slightly different. The last condition that needs to be met is that 10% condition. And if you remember, that 10% condition said that our sample size needs to be less than 10% of our population size. Okay, so it says whenever we're sampling without replacement, which is nearly always, we need to check the 10% condition, and it says n is the sample size and n is the population size. And again, because we don't know the value of p, we can replace that sample proportion with p hat. All right, so when we're looking at all those, we also need to take into consideration, and this right here is going to come up on your Chapter A test, which I will discuss what we're doing, that I have an idea for your final. that I think you might like a little bit better. It says when the standard deviation of a statistic is estimated from data, the result is called the standard error of that statistic. So when the standard deviation of a statistic is estimated, that is what our standard error is. All right, and again, here's just a little box telling you some of the same stuff that we looked at above. It's just looking at conditions 2 and 3 because 1 is sort of something we have to look at in the problem. Okay, so conditions for constructing a confidence interval about a proportion. So let's take a look at our first example. Now, I am not really sure how accurate this first example is anymore, but whenever this book came out, it must have been pretty accurate. So it says Katy Perry is currently the most popular account on Twitter, which we all know Twitter is now X, with about 100 million followers. Mr. Starnes wondered what proportion of Katy Perry's Twitter followers are female, so he selected a random sample of 500 of Katy Perry's followers. In the sample, 308 are female. Check if the conditions for constructing a confidence interval for P are met. So, 3 things we have to check. First, we have to check, is it random? Okay, so if we look back in the problem, it says he selected a random sample of 500 of Katy Perry's followers. So we can say yes, random. For me, you could just say yes and then highlight it, but on that AP test, you need to explain it. Yes, random sample of 500 followers. And technically, you should get very specific and say 500 of Katy Perry's followers. All right, so, I have a dark green, so right, check. Okay, first part done. Next, we need to make sure that our 10% condition is met. Okay, so is our 10% condition met? So that means, is my sample less than 10% of my entire population? So is 500 less than 10% of, and it says she has about 100 million followers. So we could write out 100 million, okay? And that is another check, okay? The 10% condition is met. 500 is less than 10% of that. And the last thing we need to check is that large counts condition. All right, so our large counts condition, remember we have 2 things to look at, is n times p hat greater than or equal to 10. And so remember that represents our successes. And then our failures, which is n times 1 minus p hat, is that also greater than or equal to 10. So to figure this out, my n value is 500. My sample proportion is what? 308 out of 500. And if we go through and do the math, you can clearly see the 500s cancel. So we get that 308 is greater than or equal to 10. So that part works out, but remember, they both have to. So success is getting the female followers. The failure is male followers. So if we take 500 down here, or 1 minus our p-value, which is 308 out of 500, we're going to get, I'm actually just going to write this out, we get 192 over 500. Let's make that big, since there's not a whole lot of room here. So again, we have 192 is greater than or equal to 10, so the law of large counts checks out. So we just verified that all 3 conditions were met so that we would be able to construct a confidence interval for this example. All right, before we construct a confidence interval, we need to figure out how we can calculate all of these values. So I said we would come back and figure out how to find the value of z star. So it says finding the critical value, which is that z star, for a 95% confidence interval starts by labeling the middle 95% under that standard normal curve. So if you look here at this normal curve, we know that if 0 is our mean, we have our z-star interval of plus or minus that value. The value in between is going to be our 95%, so that means we have 5% left between these two areas under the curve. So if I have 5% left between them, if we split that up, that's only 2.5% between both sides of our curve. So keep that in mind here in a little bit. So there's two ways to do this. We can use our table A to find that value with our area. I think some of you liked to do that. However, I prefer to use our calculators to figure out the area under that curve. So if we're going to use our calculator to find the area under the curve, we need to find the INV normal on your calculator. And to do that, you have to hit the second VARS button on your calculator. And then you're going to see, I don't have my calculator with me. Actually, hang on, let me pull it up here. So if we hit second VARS, you can see number 3 is our normal curve. Let me delete all the other stuff. So the 3 things you need the area that you want to find. So in this case, if we're using our regular curve we have off to the right, we want that area we said to be the 2.5%, so 0.025. And then we need our mean. So remember, this is all in standardized scores. So we need our mean is going to be 0. And then our standard deviation for those is going to be 1. So this is sort of like our z-scores that are in our standard form. Once you have those values, hit enter, and then you can see where they got that negative 1.96 from. It will give us the negative value. We just know that our critical value is the positive of that. Okay, so it's going to be the positive and the negative. So that's how they got this value, then rounding. Right? Pretty simple, just remembering how to do it. So second VARS is where we found that. So next example, it says Mr. Stars wondered what proportion of Katy Perry's Twitter followers are female. So he selected a random sample of 500 of her followers. In the sample, 308 are female. Great. Same thing. It says assume the conditions for inference are met. We already determined in the last problem that they were met. So now we have 3 things to do. The first thing it says determine the critical Z star, so the critical value for a 90% confidence interval for a proportion. So think about this now. If we have our normal curve, and now this area in the middle is 90%, that means we have 10% left between these two areas. So that's a 5% on each side. So now the area I have to find, 5% is 0.05. So we're going to do our INV norm. So the inverse normal curve. When it asks for the area, it's 0.05. Then it asks for, use the symbol, the mean, it's 0, and our standard deviation is 1. Just going to erase this so I have some room. Actually, just move it over. So substituting this into the calculator, just going to go back and change this. 0.05, we get Z star is equal to 1.645. Okay, so if they asked us to calculate something later, we now have our critical value that we can substitute into our formula, which, wouldn't you know, that's what they're asking us to do next. So part B is asking us to actually construct that 90% confidence interval for the proportion of all Katy Perry's Twitter followers who are female. So that formula is our p hat value plus or minus our z star times the square root of all of this. And you don't have to write this down. I'm just writing it down so you have it in front of you, but you can refer back to your notes. All right, so our p hat value, if you remember, that's our proportion. There are 308 female followers out of the total 500 that they sampled. Then we add and subtract, because remember, we want this confidence interval, so we want the low value and the high value. Our Z star value we just found to be 1.645. And then we have to calculate our whole proportion here. So we have our p-value, which is 308, divided by 500, times our 1 minus p, which we found earlier, 192 over 500, all over n, which in this case is 500. So I'm just going to go through and simplify a lot of this to decimal values to make it a little bit easier to do some of our work. And then 0.616 times 0.384 all over 500. And then please do not forget the square root, like I was doing earlier. Okay. So then when we simplify this a little bit more, and you could just type this in the calculator all at once. The whole thing under the radical gives us 0.0218. And then if we simplify that, we get 0.616 plus or minus 0.0358. So now we have our interval. So if I take my 0.616 and subtract my 0.0358, I get a lower value of 0.5802 and an upper value of 0.6518. So we have successfully found our first confidence interval. I'm going to highlight that in yellow because we are happy. Okay, so really wasn't that bad. Okay. Now the last part is just asking us to interpret this. This is what you guys did all last section, so this shouldn't be too bad. So they said 90% confidence, so we are 90% confident that the interval, I'll state what that interval is. I'll just say from 0.5802 to 0.6518 contains the true proportion of Katy Perry's Twitter followers who are female. So that's a little bit to take in there. The last part, pretty simple. Sort of went along with what we've already done. All right, we are moving right along because we are doing all of section 8.2 today. Okay, so second half of this is going through a process for our confidence intervals. Okay. Sorry, it's pretty late. It says we have 4 things we have to do, a 4-step process when we're doing this. First thing we have to do is state. We have to state the parameter you want to estimate and the confidence level. The second thing we need to do is plan. So we have to identify the appropriate inference method and make sure all of those conditions are met. third thing we have to do is our do. It says if the conditions are met, we have to perform those calculations. And the last thing we have to do is conclude that we are confident. Okay, so interpret that confidence interval. So the last time we did 3 of these things, they had us do the A, B, and C, but really we did the state the parameter on the previous example. Okay, so they had us do all of that, so I just wanted to sort of bring it all together and do one more example where we do everything all at once. So, it says a recent study asked a random sample of 527 college-age adults from 18 to 24 years old about their plans for purchasing a new computer. Of the sample, 105 said that they plan to purchase a Mac computer within the next year. We have to construct and interpret a 95% confidence interval for the proportion of college-age adults who plan to purchase a Mac within the next year. So our first part, and you might want to write a little bit small, is we have to state. Okay, state what they want from us. All right, so what is our parameter? So our parameter, which is our p-value, is the true proportion of college age adults to purchase a Mac. I think technically it was in the next year. So purchase a Mac, and then we went with a 95% confidence interval. All right, it says state the parameter that we want to estimate. That's what we're trying to estimate. The true proportion of college adults to purchase the Mac, and then we had to state what confidence level we wanted. Second thing we have to do is plan. Just go through different colors. Okay, we have to make sure all of those conditions are met. So for this, the last thing we did, we're going to do a 1 sample Z 4P, because our one sample, only one set of data, 1 sample was given, all right, for our p-value. So is this random, or was it random? How did they choose them? It says a recent study asked a random sample. So is it random? Yes. They told us it was random. We need to make sure, is the 10% condition met? It is met because I believe that 527 college-age adults is less than 10% of the entire population of all 18 to 24-year-olds. I would assume that 527 is less than 10% of all 18 to 24-year-olds. And the last one is the law of large counts, or large counts condition. All right, so our success is how many will purchase a Mac? And so they said 105 of them, and I'm just getting this information from here. I just don't want to keep zooming in and out. So 105 said that they would purchase a Mac, so that is greater than 10, so that checks out. And then the fail is when we take 1 minus our p-hat value, so how many of the 527 would not purchase a Mac. So we would take 527 minus our 105, and we would get 422, which is also greater than 10. so our large counts condition is also met. So far we did state and plan. Now we actually get to do a little bit of math with our do. I'm going to go over here on this side. This should give us enough room for our do. All right. So on our do, we have to find actually our confidence interval. So that's what they want us to do. It says if the conditions are met, perform the calculations. The calculations they mean, our overall goal is to get that confidence interval. So if we have our confidence interval formula, the first thing we need to find, we're going to have our proportion, which means we'll have all the values under our square root. We know what our n value is. We need to find our z-star value, or our critical number. So to find our z-star, we do inverse normal, our area. Now we need to think for a second. They wanted a 95% confidence, so that means I have 2.5% on either side. So that means our area is going to be our 0.025, because that's 2.5%. Our median is still 0 with our standard deviation of 1. So second vars, number 3. Of course, I get an add, so we're just going to go through. I already know what this value is. It's the same value we got earlier, but it is going to be 1.96. Okay, we'll type it in here just so you can see. 0.025, comma 0, comma 1. There we go. Just rounded the 9599 to 96. All right, so now that we have that value, we also know our p hat value is 105 over 527. There were 105 people who said they were going to purchase the Mac out of a total of 527. So that value is 0.199. Just taking those values, so it makes our formula a little bit easier. So our p hat value, 0.199, plus or minus my z-star value of 1.96 times the square root of 0.199 times 1 minus 0.199, all over 527. Okay, going through, doing all of that math, we get 0.199 plus or minus 0.034. Finding that, we can find our confidence interval to be 0.165 to 0.233. Okay. So now the last part we have to do is conclude. So interpret what our confidence interval means. All right, so last part is conclude. So we are 95% confident that the true proportion of all college age adults, oh my goodness, who plan to buy a Mac falls between, and then we can list our confidence interval, which is 0.165 to 0.233. All right. So the last thing we have to do, or two things. So all of that work we just did by hand can be done on the calculator. Okay, the calculator will be able to give you that confidence interval. If you plan on taking the AP test, you just need to be careful because that's under the do part. So you need to make sure that you explain it, find your z-value correctly before you type it all into the calculator. So I do have, let me scooch down here. I do have all the steps here of how you can find it on the calculator. When you're looking for it tells you to go to stat and then over to test, and it wants the 1 prop z int. So be careful, it's not number 5. Scroll all the way down till you get A, and that's the one you want. Okay, then you'll type in your x value, which is the number of successes. You'll type in your n value, sample size, and then you can change whatever your confidence level, if you want 90, 95, whatever you want. Hit calculate, and it will give you your interval once you type those in. So if I were to do this for the last problem, our x value was 105. We had 527 for our sample size. But yes, and we did want a 95% confidence. So go down to calculate, hit enter. And you can see right there, it gave us the same confidence interval that we just found by hand. All right, so last thing is choosing our sample size, because sometimes our sample size won't be there. All right, so if we are choosing to do a study, we have to make sure that our sample size is large enough. Okay, it says we may want to choose a sample size that allows us to estimate a population proportion within a certain amount of margin of error. So here's the formula for the margin of error within the confidence interval for P. So ME is margin of error. We still have our equals our critical number times the square root of P hat minus 1, or times 1 minus P hat all over N. When we're going through this, we want to solve this for N, since N is our sample size. All right. Couple things though here. It says we won't always know the p hat value until after the study has been conducted. So that means we have to guess what the p hat value is so that we can solve for n. And here's 2 ways to do it. One, it says guess a number for p hat based on a pilot, preliminary, or a past experience that they've done with similar studies. So if they give you that information, you can use that. Otherwise, we have to use 0.5 as a guess for our p hat. So then if we do that, the margin of error is largest when p hat is 0.5. So this is like a conservative guess. If we get any other p hat value when we do our study, the margin of error will be smaller than we planned, which is fine. Okay? So, last example. Formula stated there again, saying everything that we just said with our margin of error being less than that. So, last example. It says, Abby wonders about college plans for the students at her large high school, which is over 3,000 students. Specifically, she wants to know the proportion of students who are planning to go to college. If Abby wants her estimate to be within 5 percentage points, so 0.05, of the true proportion at a 90% confidence level, how many students should she randomly select? So, we want a 90% confidence interval. Okay, so with a 90% confidence interval, we need to find our Z star value. So to do that, our inverse norm to find that area. So since it is 90%, that means 10% on both sides, so 5% on one side. So the area is 0.05. Our mean is 0. Our standard deviation is 1. It is 1.645. And if you're asking yourself, yes, anytime we have a 90% confidence interval, the critical value is going to be 1.645, and whenever it's 95%, what was it, like 1.9 something, 1.96, 1.95, something like that. All right, so now we can substitute everything into the formula that's listed above. So it is our z star value times the square root of p hat times 1 minus p hat all over n, and we need to make sure that is less than or equal to our margin of error. And again, we need to solve this for n, because it's asking how many students should we randomly sample. So our z star value we just found, 1.645. They did not tell us anything about any previous studies. They didn't tell us anything about our population proportion. So this is one of those times where we have to estimate our population proportion to be 0.5. Okay, so that's where I'm going to be getting this 0.5 from for p hat. And then 1 minus 0.5, which is still 0.5, divided by n. Don't forget the square root, less than or equal to our margin of error, which it says her estimate within 5 percentage points, so 0.05. So going through and solving this, we want to multiply both sides by 1.645. And then I'm also going to simplify under the square root a little bit. So 0.25 divided by n, square root, less than or equal to multiplying both of those, I get 0.0304. Now I have to get rid of my square root, so I have to square both sides. Feel like you're back in algebra. 0.25. Some of you probably really like that. We get 0.000924116. I'm going to do a couple things at once here. Multiply both sides by n, divide by the whole big large decimal, and we are going to get n is greater than or equal to 270.52. So that's our sample size. However, we need to think about what our sample is. Our sample is people. So it has to be greater than 270.52. So 270 would not be enough. So I need to say that my sample size should be 271 students. Okay. Now, a couple little things just to tell you. We used, let me go over here. We used this value for our z-score, okay? If you were to round this slightly, you're going to get different values for your sample size. So if we used a z-star score of 1.64, your n value would be approximately 269 students. However, if you rounded this to 1.65, you would need approximately 273 students. So you can see our value is right in the middle of those two. So just know that sample size can vary slightly depending on where you round throughout the problem and all of those different things. All right, so I apologize. This is a super long video, but hopefully it helped a little bit. And you have some Khan Academy videos you could watch to also help you, and then some Khan Academy questions.